Guys, welcome back to TechDose, and in this video we will see the minimum number of swaps to make the string balanced problem, which is from Leetcode number 1963. Let's look at the problem statement. In this problem you are given a zero index string s of even length n. The string consists of exactly n by 2 opening brackets and n by 2 closing brackets. A string is called balanced if and only if it is an empty string, or it can be written as AB where both A and B are balanced strings, or it can be written as C where C is a balanced string. You may swap the brackets at any two indices any number of times, but we need to return the minimum number of swaps to make the string balanced. Okay, now let's look at some examples for better understanding. Let's say that this is the given string. In this case, if you want to make it balanced, then we need to swap the first bracket with the last bracket. So you will see a closing bracket followed by opening closing and then a closing bracket. So this required one swap, so the answer would be 1. If you look at the next string, it will require you to swap the first with the last and then these two brackets. Okay, when you do that, then you have an opening bracket followed by a closing bracket, then an opening closing bracket, then again an opening closing bracket. Okay, so we needed 2 swaps in this, so the answer will be 2. Our goal here is to perform the minimum number of swaps to make the valid parenthesis, right? So that is the problem statement. I hope it was clear. Now there are multiple observations in this problem in order to solve it. The first observation is the input says that equal count of opening and closing brackets are given. Therefore it will always be possible to make it as valid parenthesis. Okay, our goal is to change the order by swapping to make the valid parenthesis. The second observation is we don't need to care about any valid part of the input. Like let's say this is the string input s and the yellow part is showing the valid bracketization while the orange part is showing the invalid inputs. Okay, so if some part is valid, then I don't need to care about it. Only the invalid part are of importance for our problem, and if I just trim out the valid part, then this is the invalid portion, and if you just do one swap, then you will get the result. So the answer should be 1 in this case. Okay, so we need to ignore the valid part. So as I said, you need to skip the valid part, and if this is the given input, then you will end up getting a closing bracket followed by an opening bracket. Okay, so you just need to do one swap, hence the answer in this case will also be equals to 1. This is the second observation. The third observation says that the count of minimum swaps will always be equals to the imbalance count plus 1 by 2. Let's look at some examples. In the first string, you look at it, you need to do only one swap, right? So how many imbalances are there? There is only one pair of imbalance, right? So if you add one pair of imbalance to 1 by 2, then you get one number of swap. In the second example, we have 2 pair of imbalances. So if you add 2 plus 1 by 2, there will be only one swap which is required to make it balanced. If you look at the third example, there are 3 pair of imbalances. So if you add 1 to it and divide, you will get 2. And what are those 2? The first with the last and the middle 2 brackets. Okay, if you do some dry run on your notebook, you yourself will be able to understand this logic. Now in this example, you have 4 pair of imbalances. So you will have to do 4 plus 1 by 2. That means 2 number of swaps. The first one with the last one, and the third one with the third last one, and then you will see that it will be balanced. So 2 number of swaps. In the last example, we have 5 pair of imbalances. So if you add 1 to it and divide, you will need 3 pair of swapping. The first with the last one, then the third with the third last one, and then the middle 2 brackets. Okay, so we need to do 3 number of swaps. So I think this clears out all the observation for our solution. So we will see 2 techniques. The first technique will be by using stack, which is about counting imbalances. What we will do is we will start iterating from the beginning, and whenever we see an opening bracket, we will just push the opening bracket. When we see a closing bracket, I will cancel out an opening bracket from the stack. So I will just pop from the stack. But if I see a closing bracket and the stack is empty, that means we are overbalancing our closing bracket, and hence the imbalance count will be added by 1, right? Now when I see an opening bracket, I will always push the opening bracket, and whenever I see a closing bracket, then I will always pop the closing bracket. If I see a closing bracket and the stack is empty, then this is again contributing to imbalance count, and the count becomes 2. When I see an opening bracket, then I will push the opening bracket. Seeing a closing bracket, I will pop the opening bracket. When I see opening bracket, I will push the opening brackets. Okay, so in this case the number of invalid opening brackets will be exactly equals to the number of invalid closing brackets, because in the problem they mentioned equal number of opening and closing brackets are present. So two pair of imbalances are present, and therefore the number of swaps needed will be 2 plus 1 by 2. That means one swap is only needed, and you can just swap this one with the last one, and you will see that it will now become balanced, right? So this is how you can solve with stack, and the time complexity will be order of n, and the space complexity of stack is also order of n, right? Let's look at the next approach. In this approach of counting imbalance, we will be using the logic that the closing bracket count must always be less than equals to the opening bracket count, and that should always be true. If there are more number of closing brackets that you have seen than the opening bracket, which means there is an imbalance, right? So again we will start iterating from left to right, and I will maintain a counter called closing counter and the maximum closing brackets imbalance that we have seen. Whenever I see an closing bracket, I will do +1, and if I see an opening bracket, then I will do -1. In an ideal case, we should maintain a 0 value for a pair in such a way that if I see an opening bracket, I'll do -1. If I see a closing bracket, I'll do +1, so that after the pair is done, then the value should be 0. So let's now see the dry run. If we see an opening bracket, I'll do -1. I will compare always maximum closing with the closing, so that I will always keep the maximum number of closing brackets which are overbalancing. So 0 is already greater than -1, so no need to update. If I see a closing bracket, I will add 1 to it, and this becomes 0. Again 0 and 0 are same. If I see another closing bracket, then I will do +1, and this becomes 1. Now the maximum closing 0 is less than 1, so let's make it 1. If I see an opening bracket, I will decrease the value. If I see an opening bracket, I will decrease the value. If I see a closing bracket, I will increase the value. Again closing bracket, increase the value. Now 1 and 1 are same, so no need to update. If I see another closing bracket, it will become 2, and since 2 is greater than 1, so let's update the maximum closing to 2. This 2 means there are 2 closing brackets which are overbalancing at this point of time right from the beginning. Okay. Now if you look at the opening bracket, then again this value will be decreased, and it will become 1. If you see another closing bracket, this will become 2. If you see another opening bracket, this will become 1, and another opening bracket, this will become 0. At the end, the closing value will always be 0, because we have equal number of opening and closing bracket, right? So the maximum closing is actually showing me how many closing brackets are present which are imbalancing, okay, which are creating imbalances. So maximum closing is representing the pair of imbalances. What we need to do is write 2 plus 1 by 2, and we need to do one swap to get it fixed. You can swap this item with the last item and get this fixed, right? So the answer in this case is 1. In this case, the time complexity will be order of n, because we have to iterate through the entire string. But the space complexity is order of 1, because it does not matter what is the length of the string, we will just be using 2 variables, okay? So this is the most optimal approach. Let us now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. This is the simple code where the first technique shows the stack method, where I have defined a stack and creating an imbalance count. Now I will iterate for all the brackets in the string. And whenever I see an opening bracket, I will just push it into the stack. If I see a closing bracket and the stack is not empty, then I will pop. But if the stack is empty and I'm seeing a closing bracket, then this means it is a overbalancing closing bracket. So I need to just add imbalance count by 1. And at the end, return imbalance count plus 1 by 2, as I explained, right? The second approach is the order of 1 space complexity optimal approach, where we will be maintaining 2 variables, closing and max closing, and I will be iterating through all the characters. If I see an opening bracket, I will decrease the closing value. Otherwise, if I see a closing bracket, then I will increment the closing value. And I will always keep the maximum closing in the max closing variable, which will say how many closing brackets have been seen which are overbalancing than the opening brackets, right? And finally return imbalance count plus 1 by 2. So both the techniques are similar, but the second one is more optimal due to order of one space complexity. The Java and the Python code will be present in the description below. You can just go and check out the GitHub link. If you still have any doubt, then please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.